How's that?
Looks perfect.
So this is one of the projects that I've been working on as a postdoc at University of Missouri. And I just want to start by acknowledging that Jen Reedy has been sort of the lead on golden cheek warbler research at Mizzou. She's been working on this project for a long time and has published several papers. I mostly came in for the full annual cycle analysis. And yeah, and so this project is kind of a collaboration between me, Jen, Frank Thompson, and Lisa O'Donnell. And we work for MU, Frank's with the Forest Service, and Lisa is with the city of Austin. Kind of a diverse group of partners. But so I guess I'm going to start today with just a few themes from conservation biology, and I'm going to stop my video. There we go. Okay, so I'm going to start with a few themes from conservation biology, and then get into our analysis where we evaluate some of the factors influencing productivity, survival, and population viability for this endangered golden cheek warbler. And we were working in a large urban preserve in central Texas, just outside the city of Austin. So just beginning with those conservation biology themes, conservation challenges today interactively influence wildlife populations, and these include habitat loss and climate change. Wildlife today exists on remnant native habitats that are often within modern landscapes that have altered function, structure, or composition. At the same time, wildlife are experiencing novel weather patterns and shifting climate norms associated with climate change. There's a shortage of basic information on the status and trends of vulnerable species and bird groups. And so addressing these challenges requires a better understanding of how wildlife respond to environmental influencers. This figure here is from the State of the Birds report for 2022. And it basically outlines a strategic approach to bird conservation. The first step in this approach addresses the information shortage by identifying key causes for decline. Recovery also requires cooperative, community-supported solutions and addressing threats across the full annual cycle through coordinated action for long-term population stability. Oops. So conservation plans need to identify clear, measurable targets and design protected areas based on those targets. Some considerations include, will objectives require a single large or several small protected areas? Are conservation targets sensitive to edge effects? Are there any areas of nested diversity where multiple species of conservation concern can be efficiently protected? Conservation design may be influenced by logistics, cost effectiveness of alternatives, and public valuation of land or species of conservation concern. And so cooperative community supported solutions are kind of shaped by all of those things: species needs, public valuation of biodiversity, and the logistics of establishing networks of quality habitat. Population recovery requires science-based actions. With limited resources, priorities must be identified based on valuation of biodiversity, their threats, and urgency. Successful strategies consider full annual cycle and full life cycle needs. Conservation plans need to be cooperatively developed and implemented by governments and communities. And so successful strategies require coordination globally as well as local action just to achieve that long-term population persistence. Today, as kind of a case study, I'm going to talk about the golden cheek warbler conservation and research going on. The golden cheek warbler is a medium distance migrant. It breeds in central Texas. Can you all see my cursor up here?
Yep, we can see it.
Okay, so it breeds in central Texas and it winters down in Central America. This yellow is kind of the migration route. But they nest solely in mature ash juniper woodlands in the hills of Texas, and then they winter in pin oak and cloud forests down in Central America. In 1990, the golden cheek warbler was listed as federally endangered, and an endangered species under the Endangered Species Act is defined as any species which is in danger of extinction throughout all or significant portion of its range. Partners in flight have ranked them in 18 out of 20 as their continental concern score. So there's a high level of threat and a high level of urgency to protect this species. The golden cheek warbler exhibit a few life history traits that make them more vulnerable to extinction. They're habitat specialists. They breed in old growth juniper oak woodlands. They have a narrow distribution, and they also migrate across national borders. They're breeding exclusively in Texas and then wintering in Central America. They also face anthropogenic pressures, including rapid development in Central Texas and their breeding range, and then timber extraction, firewood cutting, agriculture, mining, construction, and development in their wintering range. There are 4 general steps to any conservation plan. First, you have to identify a target. Here it's golden cheek warbler. Inventory a region for the target and associated threats. Set conservation goals. Population persistence is a really common one, and design a network of conservation areas. Conservation goals are really critical for a successful plan. They have to be clear. They have to be measurable objectives with well-defined spatial and temporal, a well-defined spatial and temporal scope. They also have to follow the scientific method and anticipate change. For the golden cheek warbler, we're going to contribute to measurable objectives following the scientific method by estimating vital rates and population viability. We will also contribute to understanding of anticipated change by estimating population viability given scenarios of climate change and land use development. So our research objective was to evaluate the impact of changes in land use and global climate patterns on productivity, survival, and population viability of golden cheek warblers. And we were looking specifically in the Balcones Canyonlands Preserve of Central Texas. This preserve is 33,000 acres of mature ash juniper oak woodland. It's high quality habitat for the golden cheek warblers. It was established after they were listed as endangered in 1990 as mitigation for land development in Travis County around Austin, Texas. Land value and development pressure are high in the region, so the U.S. Fish and Wildlife Service partnered with Travis County and the city of Austin to establish a system that allowed development and protected high quality golden cheek warbler habitat. So rather than working through U.S. Fish and Wildlife Service's permitting system, landowners can apply for incidental take permits from Travis County and the city of Austin. And this will allow them to develop their land and remove golden cheek warbler habitat for a one-time fee. And then the fee goes towards funding land purchases of high quality warbler habitat and land management activities. And So the study around Balcones Canyonlands Preserve was 10 years long, and data were collected on 10 sites. Oh, sorry, it was 9 years long. And it was collected on 10 sites, 2011 through 2019. This is kind of a fragmented preserve with different levels of development surrounding each plot. And technicians went out and they counted the number of territories in each of these plots based on males who were uniquely color banded. They monitored nest success and counted the number of young that fledged per territory. And then they also tracked survival based on marker capture methods. These data were jointly analyzed within an integrated population model. The IPM was pretty simple. We were trying to estimate abundance and changes in abundance. And so productivity contributed to new individuals each year. And productivity was estimated as the ratio of the number of young hatched per adult. And then adult survival also contributed to abundance in future years. And this was estimated with marker capture methods. We didn't have any data on recruitment, which included juvenile survival and immigration, but that was estimated as kind of a mass balance within the IPM, sort of a latent process that we didn't observe. Jumping into results, here are some of our annual estimates for productivity on the left, adult survival, and annual population growth. On the x-axis, we have years from 2011 through 2018. And then these dotted lines in the center of each figure represent median estimates that resulted in a stable population. So for a stable population, we want each of these rates to hover at or above this median line, this dotted line. And so productivity is pretty stable throughout the years. There was a dip in annual survival between 2014 and 2016. This coincided with a strong El Niño event. And then annual population growth kind of hovers around stable at 1.0, except for those few years between 2014 and 2016. We calculated a correlation between each of these vital rates and population growth to evaluate which vital rates were influencing population growth, and we found that both were positively correlated. So both productivity and adult survival contributed to population growth. It didn't seem like population growth was more sensitive to one or the other. We looked at a few environmental parameter or environmental covariates that might be influencing productivity or the number of young fledged per male territory. We evaluated forest cover, spring precipitation, spring temperatures, and development. And we found that percent urban land cover surrounding the 10 plots was the only environmental factor contributing to changes in productivity. And there was a negative relationship there. And this sort of complements previous work, which found productivity was positively related to forest cover and negatively related to fragmentation. So here on the y-axis, we have number of young produced per male territory. And on the x-axis, we have percent urban land cover within 1 kilometer, which ranges from about 0 to just a little over 40%. And then for annual survival, we just evaluated one global climate pattern, and so the El Niño Southern Oscillation. And we used the Oceanic Niño Index to look at the influence on or effects on survival. And so ENSO, or El Nino Southern Oscillation Patterns, influence climate on both the wintering and breeding grounds. In 2015 and 2016, the strong El Nino events led to severe droughts down here on the wintering grounds, and sort of warmer, drier conditions pre-breeding season on the breeding grounds up in Texas. And so these drought conditions may have reduced overwinter survival. They may have reduced body condition pre-migration, but either way, annual survival was lower in years where there was a high oceanic Niño index. In this figure, the dotted line represents territory counts, and this gray ribbon represents IPM estimated abundance. And so IPM estimated abundance was, within sort of observed counts were within the 95% credible intervals of those IPM estimated abundances. With 9 years of abundance data, populations showed a weekly declining trend. Lambda was estimated at 0.95 with a 95% credible interval of between 93 and 98. And we also predicted abundance into the future based on current conditions and given changes in urban land cover and climate patterns. And these future predictions, 25 years into the future, there's a lot of uncertainty around them because they include all the variability that happened across years between 2011 and 2019. But we used posterior estimates of these abundance to look at quasi-extinction probability or estimate quasi-extinction probability. And we defined quasi-extinction as fewer than 10 male territories across study plots. And we estimated the probability of quasi-extinction 25 years into the future. So under ENSO conditions experienced in the previous 25 years and under current levels of urban development, we estimated about 17% probability of fewer than 10 males territories across the study area in 25 years. When development within 1 kilometer of the most urbanized sites increased by 10% of total land cover, there wasn't much change in extinction probability. And this was probably because those urbanized sites had fewer individuals who were producing fewer young each year. And then we ran the scenario where we increased development by 10% within the 3 least urbanized sites. And when we did this, quasi-extinction probability increased from around 17% to 25%. When development within 1 kilometer increased by 10% of total land cover for all sites, quasi-extinction probability reached 40%. We also simulated changes in climate patterns, and so there's predicted to be a higher frequency of strong ENSO events in the future. So in our simulation, we increased the frequency of high ONI years from twice every 25 years to 3 times every 25 years. And this increased quasi-extinction probability, from 17% to 19%. So our results kind of support the idea that edge effects really influence reproductive success for this habitat specialist, especially urbanization. And we feel like these results suggest management options that protect or expand current breeding habitat through land acquisition agreements or zoning laws on the breeding grounds could support population persistence. I think these results also highlight how important intensive monitoring is to linking population dynamics to a changing world. This was a really big field effort. There were 10 years of committed field crews out there collecting survival, fecundity, and abundance data. And just to kind of go to a little bit of metapopulation theory, the amount of habitat is important, but also the arrangement and connectivity of patches may be just as important. And so here we have a fragmented preserve. It's a large preserve, it's 33,000 acres, but not all patches are equal. If we look at productivity across each of the patches, some of them are lower than what would result in a stable population here in the white box plot. And so JJT over here to the west and VPWB over here, kind of an isolated patch, have productivity rates that are lower than what would be required to support a stable population. But these marginal sites may be important for persistence, but if all sites had these or similar rates, it's likely that before all habitat patches were destroyed, the population would probably go extinct in this area. So protecting those larger areas, those larger intact landscapes are important. Currently, there are calls to delist the golden cheek warbler and remove Endangered Species Act protections. There are very few laws in the US that can restrict activity on private lands, but the ESA is one of them. Another is the Clean Water Act, but listing can be a roadblock to development. And so we feel like results from these simulations of population viability under scenarios of future development could be relevant to US Fish and Wildlife Service as they respond to these calls for delisting. And yeah, I just wanted, yeah, I'm ready for questions, but also here's Jen, who's led this project over several years, and Frank Thompson, our supervisor, who supported the project continuously. Okay, thank you.
Awesome. Thank you, Emily. Yeah, so we have